Good afternoon, students. Today's lesson is on organic chemistry. We are in the 21st century, and it's only proper that our teaching and learning should be abreast with technology. And it's for this reason that we are using PowerPoint presentation to explain the concept of organic chemistry. It is my hope that students will find this technology useful in their teaching and learning. To kickstart today's discussion, I would first and foremost explain what we mean by organic chemistry. Organic chemistry is a concept in chemistry that deals with the study of carbon and its related compounds. And so, for all that we'll be talking about under this concept will have to do with carbon and its related compounds. Carbon is a very essential element in science, and that is why an entire area is dedicated to the study of what? Carbon. One would ask, why is it so? Why is carbon so important that a whole topical area is dedicated to the study of carbon? Carbon has properties or characteristics that other elements do not have. That makes it so necessary that an entire area of study is dedicated to carbon. One, carbon is able to form 4 bonds around it, which is, it is what? Tetravalent. Carbon has 4 bonds in the outermost shell that it can use in forming covalent bonds around it. And so this property makes it possible that carbon is given this preference. Carbon is able to also undergo what we call concatenation. What do we mean by concatenation? Concatenation is the ability of carbon to form long chains of carbon-carbon bonds. So it's able to combine with itself to form longer chains. And that's what we mean by what? Concatenation. We could also say that carbon is abundant. It's one of the most abundant elements. And many more of the reasons why an entire area is dedicated to the study of carbon compounds. Now let's go through the slides we have. What is organic chemistry? Organic chemistry is said to be the study of carbon, the compounds it makes, and the reactions it undergoes. And so when we talk about the study of carbon and carbon-related compounds, then in effect, we're also going to be talking about the compounds it makes and possibly the reactions it undergoes. Okay. Then we will look at one of the reasons why carbon is considered as, or an entire area dedicated to the study of carbon. And so this is one other reason that over 16 million carbon-containing compounds are known, which means carbon is able to combine with so many of the elements to form numerous compounds. And so we have over 60 million carbon-containing compounds. Then, because the carbon-carbon single bonds and the carbon-hydrogen bonds are strong, carbon compounds are stable. They are stable. The essence of bond formation is to bring about stability. And so in most covalent bonds, for example, covalent bonds are formed, particularly the covalent bonds, for stability. And so if covalent bonds are formed in carbon-carbon compounds or carbon-related compounds, then of course the main aim is to achieve stability. Again, carbon forms chains and rings. It forms chains and rings, and that is because it has the property or the ability to concatenate, and that is why it's able to form chains and then rings. The chains can be straight chain. And so that is why generally organic compounds are grouped into aliphatic, which is the straight chain or open chain. We also have what? Alicyclic, which is the closed chain or closed rings. We have aromatic, which forms what we call the benzene rings. And then we have also the alicyclic, which also forms what? The ring form. So carbon can form all these kinds of classification of organic compounds. Yeah, so we have examples of carbon-related compounds that can be formed. This is a straight chain octane. It's a straight chain hydrocarbon. This is ethyl benzene. It's an alicyclic hydrocarbon. And this is also a straight chain isopropyl alcohol. It is, and then 2-octene. It's also a straight chain. It's also a straight chain organic compound. Now, we will look at what we mean by homologous series or homologous compounds. Hydrocarbons are carbons or compounds containing carbon and hydrogen only, which means constitution-wise, if you want to look at the elements that constitute a hydrocarbon, then we will be looking at only carbon and hydrogen only. That's what we mean by a hydrocarbon, like the name suggests. So the hydro represents hydrogen, then the carbon represents what? Carbon. So we put it together as what? Hydrocarbon. Now, the hydrocarbons undergo what we call homologous series. Homologous series. Now let's see what homologous series is. Related compounds that have the same functional group, or that is group of atoms within molecules that are involved in chemical reactions characteristic of those molecules. What do we mean by that? A homologous series is a series of organic compounds with the same functional, which means they are from the same parents. So if it's an alkane, all members of the series will be alkanes. If there's a homologous series about alkenes, all members of the series will be alkenes. If it's alkynes, all members will be alkynes. And so that's why we are saying that they have the same functional grouping. Okay? Then it's also important to indicate that each member of a given series differ from the neighboring member or just the next member by a fixed mass of 14 or CH2 group. That's a very important point we have to take note. And so if the difference between two neighboring members of a series exceeds a fixed mass of 14 or is not CH2, then it cannot be considered as homologous series. It cannot be considered. Now we have example of that. Okay, but this has to do with functional groupings. And so we have functional group, example of functional group, then the class of compounds they are, then the structural formula, and then the example of the functional group, and then we have the ball and stick model representation. And so for the first one, we have the hydroxyl. The hydroxyl, that's the functional word, which is what's the hydroxyl? That is OH-OH is hydroxyl. So if you have OH attached to a compound, then we say that that is an alcohol. That's the name of the functional group, alcohol. So we have alcohol because of the OH. And so this is the structural formula. So the R here represents an alkyl group. So if an alkyl group is, if you have OH attached to an alkyl group, then that's considered as what? An alcohol. And that is why it is in the white. So this one is the one in the white is called the functional group. So it's the existence of the OH in the compound here that makes it what? An alcohol. An example is what we have here. We have CH3, CH2, OH. This one is the expanded structure. Okay? And so this is called ethanol. Ethanol. Ethanol because there are two carbon atoms in the longest chain. Then we have the OH, which is the functional. That's why it is in white. It's highlighted here, indicating that the functional group in there is what? An alcohol. That's a hydroxy. So this is ethanol. Then, using the ball and stick model to explain further, you will notice that the carbon atoms, which are the central atoms in there, are represented by the black balls, as you can see. So the black ball here is a carbon. Now there are white balls, smaller balls attached to the first carbon. That is the hydrogens. So you have three bonds attached to the carbon. So 1, 2, and then what? The third one here representing the first part. Then the second part you have carbon and 2 hydrogens. So you see that the second black ball is the second carbon with 2 white balls attached, which is what? The 2 hydrogens. Then the red ball here represents what? The oxygen that is directly bonded to the carbon Then you have the H, which is what? The white ball. Okay, so by representation, the black balls represent carbon, the white ball represents hydrogen, and then the red ball represents what? Oxygen. And so this is what we mean by the ball. Then the stick is the line or the connecting parts of the diagram. So that's what we call it, the ball and stick model. Good. Then the carbonyl group, which is the dash CHO. So if you see CHO attached to an alkyl group, then that compound is said to be is called an aldehyde, or called aldehydes. Okay, an example is, or this is a structural formula, RC double bonded O and then H. Okay, but over here the double bond is condensed, it's not shown, but once you see that, you know that there's a double bond between the carbon and the hydrogen, so the oxygen, then the single bond to the hydrogen, and that's what you see in the structure here. Good. An example is what we have here, that is acetaldehyde. Acetaldehyde. And that is an example of the aldehyde. And this is a ball and stick representation of the aldehyde, which is the carbonyl group that is attached to the alkyl group. Then we have the carbonyl. Carbonyl, what we call ketones. Ketones. For the ketones, you have the alkyl group attached to a carbon double bonded to an oxygen and to another alkyl group. So we call that ketone. And that's an example. Another example is acetone. Acetone. We have acetone. Good. And that is the representation of the ball and stick representation of it.